Hello. In this video, we are considering the distribution of the binomial, or the shape of the binomial distribution. And to illustrate that, in example 12, we have that a September 2015 article on CNET.com claims that 40% of mothers avoid family photos because they don't like how they look. So suppose this number is true and that you survey 10 mothers with this question. Well, we're going to let X be the number of moms out of that 10 who say they avoid family photos for this reason. So then that means that X is going to be a binomial random variable with N being 10 and P being 0.4, since 40% of mothers avoid family photos. And we're going to consider the theoretical distribution of this random variable. We're going to start by completing the probability distribution table for X. So to do this, we can actually do it in a calculator. We don't have to do it all by hand. We can use the binom PDF option with 10 and 0.4, but notice we are not going to put in an X value. If we do that, then it just shows all of the values. And to make it easier to read, we are going to store it into L2. And the way that we're going to get L2 is by pressing second and the number 2 button. So moving over to the calculator, we're going to go to the distribution menu. We're going to go down to binom PDF. Press enter there. We have 10 as our N value. We have 0.4 as our P value, and we are going to clear out the X value. Press enter. Then we are going to store it, which, well, let me show you real quick. If you don't store it anywhere, it will print it, but it has stuff like this. You can scroll over, but it makes it a little hard to read the entries. A better way to do it, if we redo that entry, then we're going to store it, and I want to store it into L2, so I'm going to do second, number 2, press enter. It still displays all that stuff, but now if we go to our stat menu and edit, list 2 has all of these values. Now they are rounded to the nearest, or to 4 decimal places, which is perfectly fine for filling in the distribution table. So now I'm going to flip back to the notes. I need to fill this in. So in the X column, we need to have all the possible X values that we can have. N is 10, so that means X can be 0 through 10. The probabilities here are listed in the same order. So the probability of 0 is 0.006. And if you look here, it does give you, let's see, does give you more decimals if you want to take it out more, 0.00605. Then when X is 1, the probability is 0.04031. When X is 2, the probability is 0.12093, and I am getting these I've written these down from the calculator already, since I can't show both screens very well. You can just scroll through here. This is for X being 1, this is for X being 2, X being 3, and so on. So I'm just going to go ahead and fill that in. 0.21499. When X is 4, 0.25082. When X is 5, 0.20066. When X is 6, the probability is 0.11148. When X is 7, the probability is 0.04247. When X is 8, the probability is 0.01062. When X is 9, the probability is 0.00157. When the probability is 10, when X is 10, the probability is 0.000104, and I took that out to one more decimal place just because it was so small. Now, if you compare that to the calculator gives it to you in scientific notation. That doesn't give you very many significant digits, but if you look here with more detail, 10485, it is times 10 to the negative 4, so I just shifted my decimal over a few times. On a side note, if you are putting something in scientific notation into WebAssign, you do need to do it with this E notation. So you could put in 1.05 E -4 and WebAssign will take it. You also could put it in like this by shifting the decimal place, but that is only possible if you're only considering, 10 to the -4, 10 to the -5, something like that. If it gets to be too much, like 10 to the -10, it's going to be cumbersome to write in all of those zeros that you need. So I would recommend putting it in scientific notation. You just need to write it in with the E. If you were doing it by hand, you could write it with the E, or you could write times 10 to the -4. Either one I would accept on, say, an in-class test or something like that. So this is our completed probability distribution table for X. And then in number 2, we're going to draw a histogram from this data, and we're going to use the boundaries -0.5 to 0.5, 0.5 to 1.5, and so on. So that means that we are going to consider this as one class, and this as another class, and so on and so forth. So every row of our probability distribution table will be a class. The bar heights are going to correspond to the probabilities. So I'm going to do this by using Excel, which is probably what I would have done in class as well. I'm going to take those values and copy them over here. Okay, so now to generate this, I've shown you previously how you can insert a histogram by going to the statistic chart option. But there, Excel creates the classes for you, and it's a bit more difficult to do that. It creates the classes and counts the amount of data in each one of the classes, so that's not going to work here. What I'm going to do here is I'm going to select both of those columns and create just a normal bar chart, or a column chart, as Excel calls it. And unfortunately, the default option does not work very well for what I want. So I am not going to select it. I will come here and create this. Now I'm going to select my data here. I'm going to add a legend entry. The series name, I'll come back to that. The series values are here. Those are the values that I want to plot, and we see that now. I'm going to click OK to come back here. And it guessed correctly on the axis labels, but if it didn't have the correct axis labels, you could click on Edit here, and then click on this range of values, which ends up being exactly the same as what it guessed at. Okay, so we're going to click OK. Now I'm going to do a little bit of formatting. Let's change the colors to orange, because I'm in an orange mood today. And then I'm also going to double click on these bars to hopefully bring this up. Now I want this to look like a histogram, which means I don't want any gap in between my bars. So that's why I double clicked on one of the bars to pull up this menu. The format data point, this third option here, not the effects or the filler line, but the series options, and this gap width I'm going to set to 0. And now we have our bars like that. They do kind of run together, so just to make it a little bit easier to read, I'm going to go over here to the fill and border option, and I'm going to add a border. The color, let's just change to that. And actually I want to select, that only did it on that one. I would like to select all of them, but for some reason it's not working. There, that has selected all of them. Now I'm going to go back to this option I was at before and put a gray border. And now it's just a little bit easier to read. I will add a nice chart title here. Let's say histogram of X. I don't know if I can add that little symbol formula. Let's try this. That's close enough. B of 10 comma 0.4. If, just for illustrative purposes, I wanted to add some axis titles, I could add a vertical title, I could add a horizontal title. This is the possible values of x, and this is the probabilities. Oh yes, probabilities of x. And there we go. There is our histogram. Let's see if I can copy this into the notes page. Probably need a bit more space here. Nope, that did not paste. Let's try it again one more time. Yay! That one worked that time. So there we go. There is our histogram, and we are done with number 2. Number 3, describe the distribution of the random variable, x similar to a binomial with 10 and 0.6. Oops, that's a typo. Based on this histogram. So for example, what's the shape of the histogram? What's the most frequent data value? Is the data symmetric or skewed? That sort of thing. It is shaped almost bell-like because we do have the most common value in the middle, and then it decreases to the right and to the left. So shaped almost bell-like. I'm going to change this color because my computer's a little slow today. It is not quite symmetric though, because notice we do have slightly higher here than we do there, and then we've got these, tail values over here. So that's why it's not perfectly bell-like. So not quite symmetric, but close. The most common value, which is also called the mode, is this value here, which corresponds to x equals 4. So x equals 4 is the mode. And I already talked about it being not quite symmetric, but close. It is slightly skewed. Specifically, it's slightly skewed to the right because of the fact that we have this tail here to the right, or on the right side of the distribution. So it's slightly skewed to the right. And that's about what we can say here. Now, if we had a probability that was closer to 1/2, then the largest probability would correspond to 5 instead of 4. And we would end up with something that is much more symmetric because of the fact that half of the values would be just as likely as the other half, okay? But we would still have this, no matter what your probability is, you always have this increase to whatever the, value corresponding to the mean is. We haven't really gotten there, but this is the mean of this histogram. So the mean is the most likely option, and then as we move farther away from that to the right and to the left, we get less and less likely options. If our probability is 1/2, then our expected value is going to be right in the middle, so we will end up with something that is symmetric and bell-shaped and that sort of thing. So the last part of this problem, find the mean and standard deviation. Well, the mean is just n times p, so that's 10 times 0.4 which is equal to 4, which notice is the same thing as the mode, or the most frequent data value. And then the standard deviation is the square root of n times p times q, which is the square root of 10 times 0.4 times 0.6, and that gives us a value of 1.549. And that is it for this example, which also wraps up our discussion of the binomial distribution in section